we are back at AP Review. We're doing 2010 AB BC Free Response 4. So we have this area R. R is the region in the first quadrant bounded by the graph of y equals 2 root x, the horizontal line y equals 6, and the y-axis as shown in my terribly drawn figure. Please see the actual AP score or questions to see a better graph. Part A, find the area of R. So we're going to integrate from 0 to 9, because we're going to integrate with respect to x. You could integrate with respect to y too. I just chose to integrate with respect to x of top curve minus bottom curve, right? So I want this top curve, which is just 6, minus the bottom curve, which is the 2 root x. So my a is going to be the integral from 0 to 9 of 6 minus 2 root x with respect to x. So that's going to be a 6x, right? This is an x to the 1/2, right, if it's easier to think about it that way. So when you integrate, you up the power to 3/2 and then divide by 3/2, which is the same as timesing by 2/3. So you're going to get a negative 4/3 x to the 3/2, and you're evaluating from 0 to 9, right? So you're going to get 6 times 9 minus a 4/3 times 9 to the 3/2, which we'll deal with in a sec, minus, and then a bunch of 0, because 6 times 0 minus 4/3 times a bunch of 0. Right, okay. So this is all going to conveniently go away. Great. This is where some people get kind of grumpy that the AP does expect you, quite fairly, in my humble opinion, to know how to evaluate 9 to the 3/2. So this 9 to the 3/2, there are 2 ways to do this, and I really don't care which one you pick, right? You can either treat this as 9 cubed and then square root it, but have fun with that, bro. Like, it's cool if that's what you want to do. It's not a great choice. Or you could treat it as the square root of 9 quantity cubed, which you're going to be way better at. So either way you do this, it'll come out fine, but you can do the square root of 9 quantity cubed in your head. You can get 3 cubed and get that this is a 27. You're going to have a lot harder time doing the square root of 9 cubed instead of just doing the square root of 9 quantity cubed. So anywho, you end up getting that this is a 54 minus, I'm going to cancel a 3 out of this and make this a 36, right? So you're going to end up getting that this is an 18. So that's your area in part A. Cool, you're getting 3 points for this. You're getting 1 point for setting up the integrand correctly, you're getting 1 point for getting the right antiderivative, and then you're getting a point for all this that leads to the answer. So if you did choke and forget how to evaluate 9 to the 3/2, at least you're only losing a point. Part B, write but do not evaluate an integral that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So we are not evaluating, right? This is all about whether you set this up correctly. So when we go to do B, so I'm going to redraw my graph terribly for a sec. Okay, here's the line y equals 7. What they're saying you're going to do is you're going to take this shape and rotate it around. And you're going to end up with like this thing that kind of looks like one of those coffee filters, I guess, or maybe like the end of a trumpet, right? Okay, so anytime my little slice, this is in terms of x, right? It's in terms of x, so we have a dx slice. If that slice is perpendicular to the axis of rotation, you want to use discs / washers. Now, currently in 2020, the AP doesn't actually test shells, but they change what they test in different years. So I'm still going to point out that shells are a thing that exist, and I'm still going to go back and do all of the shells problems, but this is not a shell problem. So when I do this, right, what's going to happen is this is a washer, because as you can see when I rotate this way, I end up with a disc with a hole, right? So if I were to zoom in a little bit and find a different color maybe to help, this annulus, this washer or disc with hole, right, it has, so if we look specifically at this guy, we have an outside radius, like a big radius, right? And actually, I'm going to go down, not up, because the axis of rotation is above. So I have a big radius, right? My big radius is going to be top minus bottom. Well, the trick is that this top curve is the axis of rotation. It's 7. And the bottom curve is the 2 root x. But I also have this little radius, the radius of the hole, which is going to be the top, still the 7, minus, and then you can see that this inner value is just 6. So my little radius, you can write it as a 7 minus 6, and you can leave it that way. If you want to make 7 minus 6 a 1, great. But if you do that and you end up wrong, well, that's not great. So when we want the volume of a washer, or rather the area of a washer, the way we find it is by taking the big circle, right, the big outer circle that has radius big R, right? And we subtract the whole, which has radius little r, right? That's the whole. So that's how we get this shape that has essentially a donut, right? It's an annulus, so it's got the big circle and then a hole cut out of the middle. So what we're going to do in order to find the area of this thing is pi big R squared, sorry, switching colors, pi big R squared minus pi little r squared, right? And that's what we need to do. So our job was just essentially to set up and figure out what the r's were. So my answer ends up being that the volume of this thing, I'm still integrating from 0 to 9 because I started rotating at 0 and I ended rotating at 9, is going to be the integral from 0 to 9. And it's up to you if you want to yank the pi out in front. I don't care. So if you want to yank this pi out as a GCF, you can, right? And then it's going to be big R squared, which is 7 minus 2 root x whole quantity squared, minus little r squared, which is 7 minus 6. And again, if you want to make that 7 minus 6 a 1, great. But you don't have to. The AP doesn't expect you to do. So 7 minus 6 quantity squared with respect to x, and that is my integrand, right? So in this situation, you're getting 3 points. You are getting 2 points for the integrand, right? So 2 points for this, and you're getting 1 point for having the limit and the constant. Now your constant could have been in the integrand if you didn't put it out pull it out like I did here, and that's fine. But a couple things to be mindful of. If you miss the dx, you lose one of those 2 points for the integrand, even though realistically you might have had everything right, but oops, you forgot the dx. Boy, does that stink, so don't do that. If you forgot the bounds, or you forgot the pi, or you accidentally did big R minus little r quantity squared, that's not right. You don't want that. You want big R squared minus little r squared, right? So that was worth 3 points. All right, let's do part C. Part C. The region R is the base of a solid for each y from 0 to 6. The cross-section of the solid taken perpendicular to the y-axis, that's important, perpendicular to the y-axis, is a rectangle whose height is 3 times the length of its base in R. Write, but do not evaluate an integral expression that gives the volume of this solid. So, tricky humans. All right, here's what they did. So, we've done these base of a solid questions before with like a defined cross-section, and that's exactly what you're looking at here. But here's where they're tricky. The defined cross-sections are perpendicular to the y-axis. So what they're saying is, let me grab a different color. What they're saying is, in this direction, there is a rectangle that whatever this base length is, it comes up 3 times as high. And then up here, there's like a giant one that's going to come way up, like it's huge. I can't even draw the rectangle, it's so big. Okay, so whatever this base is, the height is 3 base, right? Okay. So the trick here, though, is that in order to find the base, you're going to have to do right minus left. Like that's a horizontal line, right? So in order to find that base length, you're going to have to do the right curve minus the left curve. And the other thing that's important is you're integrating from 0 to 6 with respect to y. So it's dy. So the tricky piece of this problem is you need to solve this guy for x. So I'm going to get y over 2 equals root x. So I'm going to get y squared over 4 is my x, right? That's what I need here. So my right curve is y squared over 4 minus my left curve is just where x is 0. So that's nice. So once I know that's the base, right? Base is y squared over 4. I know the area of one of these rectangles is base times height, which is base times 3 times the base, right? Triple the base. So I'm pretty sure the area of one of these rectangles is a 3 times a y squared over 4 times another y squared over 4. So I'm pretty sure I get 3 y to the 4th over 16. And you don't have to simplify that if you don't want, but that's what I get. Okay, so that's the area. The volume will then be what happens if I integrate from 0 to 6 because the dishes are going this way, right? It's with respect to y. 0 to 6 of 3/16 y to the 4th with respect to y. And again, what's funny is they don't want you to evaluate it, but that's a fairly easy one for you to evaluate. Like, that wouldn't be hard to integrate, but they don't want you to. So here's where you got your points. You got 2 points for the integrand. You got 1 point for the answer. Meaning, I think what they were giving you points for when they say 2 for the integrand is they were giving you points for the work along the way, like figuring out what the base is in terms of y, figuring out what the height would be in terms of that y also. So anyway, that's your part C.